All right, that worked. So what's this one about? Is this a scientific notation problem? Yes, it is. So we'll hold off on that for a bit. Anything else from homework that's not scientific notation related? Okay. So let's do a little review. Oh.
Yeah. 5.1, number 45.
45? So 12D9 over that one? Okay. Alright, so this is a decent, what was this, 12D9 over 15D squared?
Yeah.
Okay. You're dying, poor little dude. So let me ask you this. The fact that those are there doesn't change what I do with that. That's still 12 over 15. We still do the same thing we always would do. We just about reduce, yeah. So what's that become?
4. 5.
Yeah. Now looking at these, you got two ways to do that. In this case, they both end up in the same exact place. One way to do this is, how many D's cancel?
2.
How many D's cancel? 2. How many D's are left?
7.
Where?
Top.
There you go. Or the rule is 9 minus 2 is 7. So it does come out to be D7. I like it. But the other way to look at it is less going by the rules and more doing what makes sense. Which is really why the rule is the way it is. How are we doing so far? Is that cool? No, of course, that's got to be cool because you just did the proper. Yeah.
And because the 2 is canceled out, there's no D on the bottom?
Totally. Right? The bottom lost 2 D's. So what's left down here? And you could actually do this. Actually, no D's are left down there. But what is D to the 0 power? 1. Times 5 is 5. I like it. I like it. Anything else from homework? Stuff. Okay, all right. So a little review. How to do this here. Yeah, look for your numbers. Do them first, right? Numbers, and then, they always work the same. What do you think the person is thinking that would do this? This is not right, but they would see this and they would put. Where would that come from? Subtract. Yeah, we never subtracted them. It's division. But then they say, well, you're subtracting these numbers, and that's where I remind them there is no 4. There's no 4 anywhere in this problem. There's no 4. Anywhere in this problem, there's not a 4 anywhere. And that's where I get my people to come up and say, Jeff, are you feeling right, Jeff? And why am I saying there is no 4 in there? Because that means there are 4 B's. There's no 4. Do you guys get the importance of understanding that? Because, yeah, I do different things with exponents. Of course I do. Help me out. What's so what's a cubed divided by a squared? A. Is that cool? 3 minus 2 is 1. What is 27 divided by 9? 3. Did I subtract these? No. But how can I write 27? 3 to the third. How can I write 9? 3 to the second. And then what would 3 to the third divided by 3 to the second be using that property? 3. If I write a number in exponential form, then the rules apply. There are rules we've set already for numbers that are just numbers, and those rules can never change. Then we made rules based on what if those aren't really numbers? They're telling me how many of these things there are. It acts differently. Of course it does. Why would we think they'd act the same? They're not numbers. right? This is not a 4, that's 4 B's. You guys kind of see what I'm saying here? Because I know as a student, you're like, well, before we did this, and now we're doing something totally different. If you ever feel that way, come see me, because you are looking at it wrong. Nothing we learn can ever change. Yes, maybe? Okay. All right, so all this signs should go away. So what's the right way to do this?
2 over 5.
Yeah.
Divide by 3.
2 over 5. And then what is it that I suggest you do? This poor 4 has been worked over. There we go.
Move a to the negative 30.
Yeah, anything with a negative power wants to flip. Right, 4-letter word starts with F. You can say mixed couple. So those 3 go down, and that 1 goes up. So how many A's on the bottom now?
5.
5. How many B's on the top now?
5.
5. Done. Next. Now watch. The rule has to work. What do I do with the exponents here? Subtract them, right? What's 4 minus negative 1? 4 plus 1, 5. But doesn't that suck? Isn't that easy to make a negative mistake? So I'd much rather move them so there's no more negatives, because that's where I make mistakes, is with negatives. Yes, even me. Right? Humans make mistakes with negatives. I like it. Okay. Okay, cool. What about this one? I like this problem, so this is something to realize.
So if you like it, does that mean it's going to go like this?
Oh, hell yeah. That is my way of saying that. This is really a problem about what is being raised to a power. First off, what is something to the 0 power?
1.
It's 1. We proved it a few different ways. If you missed the proofs, that's one thing. If you were here for the proofs and you still think it's 0, that's bad. All right. Anything to the 0 power is 1. I like it. You guys with me?
So 7x minus 5y.
So this is something to the 0 power. So that is,
7x.
7x.
7.
Oh, 1.
what did we, all right, let me try this again. Let me try this again. Does 0 equal 1? No.
Right.
Right? Let's start there. Does 0 equal 1?
No.
No. So I'm not saying that x to the 0 equals x to the first. That would say that 0 equals 1. That is bullshit, right? Go away. Die. 0 does not equal 1. Anything to the 0 power is 1.
It's just
Because how many 7x's do I have?
0.
None of them. So then what shows up here, the understood 1 is there. Remember that? He's always there for us, right? He shows up when everybody else dies, which is really freaky, but oh, that's what he does. Over here, what's being raised to the 0 power? So is the 5 changed to 1? No, it's minus 5 times y to the 0 is 1. So then I get 1 minus 5, negative 4. Kick ass.
So is that 1 because it has the parentheses?
Yes. So what's being raised to the 0 power? 7 is, and x is. So 7 0 is 1, times x is 0 is 1, times 1 is 1. I like it. So what would really be evil is if I gave you a problem like this. Right? That would be so evil because somebody would start to, oh shit, oh screw you, Chuck. Right? It doesn't matter what this shit is. What's the answer to this? 1. Yeah, anything to the 0 power is 1. Yes?
I'm very confused on why you subtracted the 1 from the 5. Is it just because...
So what's this say? This says whatever this is, minus whatever this is.
All right,
So it's 1 minus 5.
Yeah.
Yeah. Cool. I like it. I like it. You would, Jeff. All right. All right. So let me see. Do I have any? I do. So let's talk about scientific notation, and then I'll let us do this worksheet. So I'm going to do a couple examples that show why it works the way it does. They're not necessarily numbers I would use scientific notation for normally, because they're small, but I want to work with something easy to see why it works the way it does. So let's do 4,000. What's another way to write 4,000? Does anybody remember like place value? How would you write that? You got 4 whats? 4 whats, obviously. 4. This is 4,000, so I got 4 thousands. This is the one place, by the way, that x still means multiply. It's just a part of the notation. You with me? I like it. Somewhere I saw in a book, x cubed is x times x times x, and that drove me a little insane. Right. And then I 5, 3, what the heck going? How can I write 1,000 using exponents? How many tens is 1,000? Which is really asking you how many zeros do you see? 3. So this is 4 times 10 to the third. Scientific notation is not just symbols that mean something. They are problems that work out to what they mean. I like it. How are we doing so far? Does everybody know a little bit about scientific notation? Scientific notation has to look like number, dot, maybe some other stuff, times 10 to the something.
Oh, no, not
You
a
good?
question.
All right, here's another example. Somebody help me out. How do I write that as a fraction? 4 over what? What place is it in? Thousands. So this would be 4 thousands. Did we just say that 1,000 is 10 cubed? Does it look like this? Number times 10? No. So what do I have to do with these? I have to force them up. And if I do that, are they going to be happy? They like it down there. They're all, oh, so nice. And then I force them up, and they're like, oh, screw this shit. I'm not on that. Whatever.
That's how they feel.
That's how they sound. Little jerks. Just get up there. Shut up. Now notice, now we can see some, all right, this is the work behind why the way we do this works. As a young man, and still now, I have trouble with left and right. I have no problem admitting that. Too much other shit in my head. Somebody's giving me directions, I do this on the wheel. Turn left. Oh, the one that makes an L is left. Yay. I have no problem admitting that. So when they taught us this thing, and this is really dumb, by the way. It's not just young Jeff being a little stupid and not knowing left and right. Positive power, they would teach, move it to the right. No. Positive power means big number. Big number means positive power. Because what does a negative power mean? Am I actually multiplying? No, a negative power means I'm dividing, which means that comes from a small number. So why is it 3? Well, how many times do I move the decimal place here? Because that's related to how many tens. And here, the same idea, how many times do I move the decimal? That's why it's 3. Why is it negative? Because it was small. Smaller than 1. Right? So the shortcut for this, if I wanted to write 42, 8, there. 42,800,000 as in scientific notation, where's the decimal? Tail end. How many times do I have to move it until there's a single number? Now I have, you know me. You know I have a weird way to look at this. I think of scientific notation as a 10 vampire. It wants to suck all the 10s out of something. So I don't want to stop the decimal anywhere except until I get a number that's between 1 and 10. If I stopped here, that's 42. It's got a 10 in it still. So how many times do I have to move it? I got to get it all the way to here.
7.
3, 6, 7. Kick ass. So it'll be 4.28 times 10 to the. Why not negative?
Because they're going.
Because it's big.
Oh.
I got to multiply by 7 tens. I don't want to divide by 7 tens. Big positive exponent. Positive exponent, big. So what if I went the other way? What if I have 5.19 times 10 to the negative 6th? Do I want to make it small or big? Small. So Jeff is like, good, I move it that way. Whatever way that is, doesn't matter that it's left. I just make it small. And here's a shortcut. I gotta always move it once. So how many zeros am I gonna have? Because I want to move it a total of 6 times.
6 zeros.
5 zeros. Move it once. I have 5 more to do. So I'm gonna have 1, 2, 3, 4, 5. Why will not? So 1, 2, 3, 4, 5, 6. So if it's negative, there's always one less zero in front than what it is, because I got to move it once to get around that whole number. How are we feeling about this? Does this sound familiar? Hopefully most of you have seen this before. If you haven't, hopefully it makes sense. Why do we do this shit? Because, for example, in astronomy, I'm talking about stars that are like 10 to the 7th kilometers away. Does it even matter that it's 3 times 10? No, I just want to know the 10 to the 7th part. All right? 10 to the 6th would be 1/10 as far away. So we actually kind of focus on this piece of it. Same kind of thing in chemistry, where you're dealing with protons that are like 10 to the negative 28, or what is it, 31 for electrons? 10 to the negative 31 kilograms. You know, freaking electron, thankfully, is not very heavy. Right? Oh man, there's an electron. Sorry. We don't have to suddenly know science, don't freak out. But these are just places where we use this notation so we're not writing all these stupid unnecessary zeros. You kind of with me? Alright, so let's find out if you are. I want you, so this sheet reviews everything. If you want to do number 2 and 3 first, they're the scientific notation problems. Since we just did this, it's up to you. You do whatever order you want to. You can work together if you want to. If you don't like people, you can work alone. If you weren't here the last few days, you might want to buddy up with somebody who was.
Yes.